Another thing I really like is contrast. And right now, if we look at all of this stuff, we have tons of really geometric shapes, lots of right angles and everything. And even with our kind of internal structures that we made that have some organic shapes, I still feel like having some contrasting organic elements would be really, really cool. So let's explore just a couple of simple things that we can do with VDBs in Houdini, and let's make some like organic growth on the surface of this thing. So what I'm going to do is start with basically these two streams, and I'm going to merge them together into another stream. We're just going to grab both of these and merge them together. There we go. And what I want to do is I want to start with a whole bunch of points on here. So we're going to throw in scatter sop, just like we did with our kind of organic internals, except this time we aren't going to scatter in the volume, we are going to scatter on the surface. So we're going to scatter a bunch of points. Let's turn off relax iterations. It just kind of slows things down. We don't need the points to be super evenly spaced. Let's do 10,000 points. We have a whole bunch of points on there. So right now, I have points everywhere. I kind of don't want points everywhere. I do want to have a little bit more control over where these points are going to go. What I'm going to do is throw in a sphere. And on this sphere, we're going to reduce the radius way down. We're going to turn this into a polygon sphere. And we're going to throw in a transform so that we can move this sphere around. And let's look at all of these shapes. I'm going to use this sphere to transfer attributes to these points and then delete them based on that attribute. So what I want to do is basically move this sphere sort of down towards the corner, something like this. And then I want to give it an attribute, and let's just give it a simple point attribute and an attribute wrangle. I'm going to say f at, let's call it temp for right now. We'll set that equal to 1. And then over on this side, we're going to set it same attribute equal to 0. We're going to do an attribute transfer. And I'm going to untemplate this. We don't need that. We're going to transfer to here from here. And we're going to say don't transfer primitive attributes. We only want to transfer temp. So let's throw in a color sop just so we can see what we're looking at. So we're going to go ramp from attribute, point attribute, and temp is our attribute name. And right now everything is white. But if I go here to the attribute transfer and I start pulling back that distance threshold, we're going to start seeing those things turn black if I deselect my attribute transfer. There you go. That's cool. Let's go ahead and expand that just a bit. That's great. Cool. So I'm not really worried about the color. What I do want to do is delete them. So let's throw in a delete sop. And let's say we're going to delete points. We're going to delete by expression. We're going to say at temp is less than 0.5. So if temp is less than 0.5, delete the points. Great. So now we have these points just sort of hanging out on the corner. Let's turn those into something kind of organic and nasty looking. So we can do that using VDB from particles. So it's basically going to take these existing points and turn them into a VDB based on various parameters that we set up in here. So let's take the output of delete and we'll throw it into VDB from particles. And we're going to get sort of a weird blobby mess, but we're going to fix that. One thing I want to do is reduce this minimum radius. I'm just going to take that all the way down. And then we're going to reduce this point radius scale. And you can kind of see what it's doing is it's creating VDB data on each of those points. Now my voxel size is really large, so I can't go too terribly small, otherwise they start disappearing. So what I need to do is reduce my voxel size down so I get more detail in here. So let's go 0.01. There we go. That's looking a little more gross. I like that. It's certainly very organic compared to everything. But right now, all of my points are the same size, which is okay, and we could probably go with that. But I think I want to vary that up a little bit. So before our VDB from particles, let's go in here to our delete stop. Let's throw in an attribute wrangle. And what I want to do is I want to find out the distance from each of these points to this sphere. So I want the points that are closer to the sphere to be bigger and the points further away from the sphere to be smaller. And that way we have this kind of mass in the middle that falls off as it gets further away. So we need to find how far they are away from this sphere. Now the sphere has tons of points on it. But I could just say, throw in a delete stop, and I could delete 0.0, and then say delete non-selected, and all I have left is this point here, and that's fine. It doesn't need to be super accurate. I just need a point. So I'm going to plug that point into my second input here on my attribute wrangle. And we're going to set up a couple of little expressions here. So what we're going to do is we need to create an attribute called p-scale that we've used before. And p-scale in this case is going to determine how large or small the area of that VDB is around that individual point. So we want larger p-scale closer to our sphere, and smaller p-scale the further away we go. We want a little bit of control over that as well. So let's set up a attribute. Let's say at p-scale is equal to, let's use the distance function. So distance between my current point, and I need to get the point coming from input number 1. So actually, before we even do this, let's go up here and make a vector variable called inPoint. And that's going to be a point function. We're looking at stream 1 this time. We want the p attribute, and it is 0.0 because we only have 1 point. Okay, we can use that down here. In point. So p-scale is going to be set up to be the distance from the point being processed to this endpoint, which is our point that's coming in here from the sphere. Okay, let's see what that does. So that actually does the opposite of what we want. We have smaller points here and we have larger points here, right? Because these are further distance from the sphere than these points are. Okay. So what we can do is we could do a whole bunch of trial and error and math and everything, or we could just use a fit expression. So what I'm going to do is do a fit, and I'm going to use the input of the fit, this distance here. I'm going to keep that there. I'm going to say the distance goes from 0 to 1, and I'm going to fit that from 1 to 0. And now we've got kind of the opposite. It's not quite working yet, but we'll get it there. So we don't go all the way to 1, all the way to 0. Let's try 0.5. And let's not go all the way to 0 here. Let's go to 0.5 here. All right, that's a little better. Let's say 2 is our max distance. And 0.2 is our minimum size. And let's say 3 is our maximum size. 3 might be too much. Let's try 2. And let's try 1.5 is our max distance. So it's a little trial and error, but that's feeling pretty disgusting right there. That's cool. Let's try 2.5 for the max. Great. Yeah, that feels like sort of a nasty mass right there. Cool, I'm digging that. So right now, we just have a VDB. We don't have any polygons or anything. So we can do a VDB convert. And we can convert this VDB to polygons. So now we actually have polygons from that VDB. Cool. All right, so this is getting gross, but I think we can make it a little grosser looking. So let's throw in an attribute VOP. And let's push some of these points around a little bit. So we're gonna do a turbulent noise in here. And we are going to add the result of that turbulent noise to our current point position and basically displace this geometry. I'm going to throw in an add VOP. We're going to add point position to turbulence. So turbulence needs the point position to generate the turbulence from. That goes in there. And then we're going to generate some 3D noise. I'm going to take the output of this and plug it right into that add. And it looks totally broken. So let's do this. Let's up the frequency first, which actually makes it look even more broken. But then we'll reduce this amplitude down to say like 0.01. That's too small. That's a little better. Maybe we do like a simplex noise or something like that. And we can even up the frequency on this a bit. We can go even further up on the frequency and reduce this down. Yeah, so we're starting to kind of push those points around a little bit. We can even do another turbulent noise and add this one in there too. And maybe this one will do like a sparse convolution or like a purlin noise or something like that. Let's see. Let's look at alligator noise, maybe reduce the frequency a bit so we get some like bigger blobby areas. There, I think that looks sufficiently gross.